All right, hello. Today we are going to review graphing using a table of values, graphing quadratics. And remember, quadratic equations, the ones we're going to graph in this video, are in the form ax squared plus bx plus c. Okay? I know that's sloppy. I'm trying to write with a mouse, so this is our form. And the first thing we have to do is find the axis of symmetry, and that really requires a formula that is negative b over 2 times a. Okay? And remember, negative b just means the opposite of b, and they're talking about this number, not the x, just the number next to x, the linear portion of the quadratic equation. And then the a, again, refers to just the a, not the x squared. All right? We are then going to take this value and put it back in to our equation, 4x. All right? In fact, the axis of symmetry is the value of x, essentially, that cuts our parabola in half. All right? So this is an x equals equation. When I plug in negative b over 2a, I know essentially that my graph would be along maybe some imaginary x equals line, in this case some negative number, and then my parabola would open up from there. Okay? So like I said, that's kind of step 1 and 2. So we're going to find this value, plug it into our quadratic equation to get the y, because we need to make a table of values. Okay? And we're going to choose two values directly to the left or right. I try to avoid negative, or at least I tell students to avoid negative numbers. If you can use 0, if it's directly to the right or left, that's usually a good one to use. Okay, and then we're going to plot those 3 points, the vertex, and then the 2 points we find, and then we're going to reflect those across the x-axis. So essentially, the steps of your problem are going to look like this. You're going to get some value for x, okay, and we're going to put it into a table, x, y, and we're going to get some x value. Let's just pretend we get 3. All right, and let's pretend when we plug it in, we get, I don't know, 5. Who cares? And then we're going to pick, this is what this part means, 2 values to the right or left. I'm going to pick 2 and 1. Both are positive, which is, a plus, no pun intended. They're smaller than 3, so that should make it easier when we put it into the quadratic. And we might get like, I don't know, 6 and 8, something like that. And we would then plot those 3 points. 3, 5 would be over here. 2, 6 would be about here. Actually, 2, 6 would be about here. And 1, 8 would be somewhere up here. And then we would reflect those across and make our parabola. So that is what your progression is going to look like. You're going to go from this. You're going to put it into to get the y value of your vertex. You're going to pick 2 values next to x. Like you're going to get some crummy x axis, so some crummy x value. Could even be negative a half or negative 3/4, but then you're going to pick the next 2 whole numbers next to it, plug those into the quadratic to get the y's, plot them, and then reflect, and there's your parabola. So let's look at 2 examples. So here's our first. In fact, I'm going to do this one first because it ends up being slightly easier, and then we'll go to this one. All right, so let's do the 3x squared minus 6x plus 2. So step 1, we're going to use the negative b over 2a, the formula for the axis of symmetry, x equals negative b over 2a. All right, and I'm going to put that into the equation. So remember, negative b just means the opposite of b. So if b is negative 6, the opposite of that is 6. All right, and then 2a, 3 is a, next to the x squared term, so 2 times 3, which is 6 divided by 6. 2 times 3 is 6, which gives us 1. Okay, and then I'm going to make my table of values. So I have my x coordinates, my y, and our x coordinate of our vertex is 1, and I like to label that 1 so I know this is my center point. This is my vertex. This is where the graph changes direction. Okay, and I have to take this number and I have to put it into the quadratic equation, 4x, and we have to follow order of operations. All right, so what I do is I'm going to square 1, multiply it by 3. I'm going to multiply 1 by negative 6, and then I'm going to add or subtract all those numbers. So for the first one, I'm actually going to write it out, but for the rest, I'm going to skip a few steps. So 3 times, just so you get the colors here, show you what I'm plugging in. 1 is our x, okay? So 3x squared minus 6, I'm going to kind of put an open parenthesis there, plus 2. And again, I'm putting this 1 into the formula. In fact, I think I'm going to go over this with red so you know what I'm doing. And I'll make that red. Okay, now order of operations wise, this becomes 3 times 1 squared. 1 squared is 1, so I have to do that first. And that leaves me with 3 times 1. And again, I'm not going to show all these steps after this one. Minus 6 times 1 is 6, plus 2. 3 times 1 is 3, minus 6, plus 2. And then I'm going to kind of speed this up. 3 minus 6 is negative 3. Negative 3 plus 2 is negative 1. So that is my vertex. Okay? And before I even write or I even draw a set of axes, an x and y axis, I want to see where these numbers are at so I know whether I got to put the x-axis low or the x-axis high before I decide where this is going to go. Now, this is what I mean by I'm going to pick this up a little bit. I think I have, black selected. So this is kind of how I do it. I'm going to pick 2 points in this case, to the right of x. So I'm going to pick 2 and 3. Some people say you might want to pick 0 and negative 1. That's fine, but I know that a lot of students struggle with this negative 1 squared piece. And so if you can avoid it, I say avoid using negatives. Although you could use 0 and 3. That would be a pretty slick way of getting the right answer. But let's just try to keep this one simple. So anyway, we have 1, 2, and 3. So I'm going to now plug in 2. So this is what I mean by speeding this up. I can say 2 squared is 4. 4 times 3 is 12. All right, and this is kind of what I do. Minus 6 times 2 is 12. 6 times x, 6 times 2. And then plus 2. 12 minus 12 is 0, so all that's left is 2. So that's another point. And then for 3, 3 squared is 9. 9 times 3 is 27. Minus 6 times 3 is 18. Plus 2. This ends up being 9. 27 minus 18 is 9. 9 plus 2 is 11. So I got to get all the way up to 11, and I really don't have much in the negative as far as y goes. So I'm going to put my x-axis down here, and my y right in the middle. That should be okay. Okay, and I'm going to plot these points. And again, I'm going to kind of get my vertex is going to be somewhere along here. In this case, it's going to be right here. And then I'm going to get I'm going to get this half of the parabola. I'm going to reflect over and get the other half. So my vertex is 1, negative 1, which is right there. And then 2, 2 is my second point, my first point to the right of the vertex. So 1, 2, 1, 2. One thing I want you to notice with this a value is 3. So my first point next to the vertex, so I think of this as 1 squared is 1, and 1 times 3 is 3. 1, 2, 3. And I can do the same thing if I did 2. 2 squared is 4. 4 times 3 is 12. So when I cut up to 12, I'll be at 11. That's kind of a shortcut to do it if you know what the vertex is. You can kind of just figure out the other points. But for now, let's stick to this. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, just enough room. Okay, now I'm going to reflect these. I'll choose a different color. So when I'm 1 away from my vertex, I'm at y equals 2. So I want to do the same thing here. Just get 1 away and be still at 2. And then when I'm 2 away, that's the negative 1 point, I'm up to 11. So I want to again be the same thing. And then I'll see how well I can connect this with a mouse, but not very good. Oh, it's terrible. There we go. And, oh, missed it. And missed it again. Yeah, all right. Should be a much smoother than that, but looks like a 3-year-old drew this parabola. That's okay. We have the points. Those are important. We have half of that table of values. That's important. Now, for this one, I'm going to have to speed this up a little just because I'm running out of time. But when I do negative b, so negative 2 over 2 times negative 2, that is positive 1/2. Okay, so this negative and that negative, there should be a parenthesis there. It's -2 over -4. -2 over -4 is positive 1/2. So that is the x value of my vertex. And so I get 1/2. And you know what? I think I'm going to do some negative values here just to show you. So the next closest integer to 1/2 to the left is 0. That will make finding that point really quick. And then we're going to use -1. And as long as you know that -1 squared is positive 1, not -1, you shouldn't have an issue with this negative. I thought I might as well show you. So when I put 1/2 into this equation, okay, 1/2 squared is 1/4, okay, and -2 times 1/4 ends up being -0.5. Check it with your calculator if you need to. And then half of 2 is 1, so this is +1. Whoa, +1. Sorry about that. And -1. Again, this is +1. I had too much. Let's see if I can erase it. I don't have a ton of time. I got about 3 minutes left to solve this problem. So, again, +1. And +1 minus 1, it cancels out. It's 0, and that leaves me with -0.5. The beauty of using 0 is that cancels, and that gives me -1. And then -1, -1 squared is 1. -1 squared is 1. 1 times -2 is -2. And then -1 times 2 is -2. That's -4. -1 is -5. I know I went kind of fast, but I am running out of time. So I'm going to plot these. None of these numbers are particularly large, so I'm going to put my axes right down the middle. Try to be neat. As neat as I can. There we go. And so I'm going to plot 1/2, -1/2, which is about right there. I'm going to plot 0, which is at -1. And that's a good thing because this a value is negative. Our parabola should open downward. Okay. And at -1, we're at 1, 2, 3, 4, 5. Okay. Almost done. And then I'm going to reflect. This is half away. So when I'm half away, I'm still at -1. This is 1.5 away. So 1.5, half and 1 is there. And oh, that's a terrible parabola again. It's hard to draw these with a mouse. There we go. The important thing is getting these points in sound. And when you're working on pen and paper, you should be okay. I hope this video helps. I know it was a little quick, but if you like it, leave a comment. See you guys next time.